All right, so hello everyone and welcome to another Jakarta Tech Talk. Joining us today we have Reza Ram and Graham Charters to discuss powering Java on Azure and Open Liberty with OpenShift. So without any further delay, Reza and Graham, it's over to you.
Thank you. So thanks for joining everyone. My name's Graham Charters. I'm a technical product manager at IBM and I'm responsible for Open Liberty, which is what we're going to see and hear about today, and Reza's going to demo. I'm also responsible for WebSphere Liberty, which is the commercial version of Open Liberty, and traditional WebSphere, which you may have heard of from history. So what we'd like to do today is kind of talk a little bit about, I'll start by talking a bit about, I guess, some of the industry movements, if you like, or directions that mean that we're seeing from our users' perspectives, and how that's kind of influencing what we're doing, and kind of motivating what Reza's going to demonstrate. I'll talk a bit about Java EE and Jakarta EE and MicroProfile from a perspective of Open Liberty and why we feel it's incredibly important, and the importance of the kind of compatibility certification and so on. I'll talk a little bit about why Liberty, why I think it's a good runtime for doing these kinds of applications, and then we'll get into the kind of the meat of the session, the fun, which is where Reza will demonstrate Liberty on Azure and OpenShift with a Jakarta EE application, and then we'll wrap things up with a couple of slides. So essentially what you're going to see is the result of a kind of collaboration between IBM and Microsoft. And the reason why we're kind of interested in collaborating in this way is, so WebSphere has been around for a long time, so since the late 1990s. A lot of people, and Java EE has been around for the same amount of time, and a lot of people have written enterprise applications over those many years that were designed as monolithic applications to run on premises. And of course, you don't need me to say this, but cloud has changed things quite dramatically over the recent years. And although you hear a lot about new cloud native applications being written, a lot of applications that are actually running in the cloud were born on premises. They weren't written to run on the cloud originally. So this comes out of the IBG survey from 2020. Also, a lot of enterprises are actually choosing to run on multiple clouds. So multiple public clouds, but they're also modernizing how they run applications on premises, so adopting Kubernetes, for example. And so therefore they're into this need to be able to deploy in multiple environments, hybrid cloud environments. And so that kind of motivates the use of something like OpenShift, which Reza will demonstrate. And lastly, it's quite a rapid rate at which things are moving to the cloud. And the last stat I've got is 59% of responders to this survey actually expect all or most of their applications to be running on cloud on public cloud by the end of 2021. So that's a huge number of applications. Now, when we look at what technologies are being used for applications in the cloud, I think it's fairly clear now that kind of two of the big winners are containers for the kind of lightweight virtualization, to be able to isolate your applications in a lightweight way, and Kubernetes is the way of orchestrating those containers. And here's just a few stats from a Red Hat open source survey that showed that actually 84% of responders said that they are using containers today, either in development or production. 72% expected their use to increase over the next year. And 66% said that Kubernetes is either very or extremely important to cloud native. So it's kind of becoming the de facto choice. Containers and Kubernetes are becoming the de facto choice for cloud native deployments. So where does Java EE, Jakarta EE, and MicroProfile fit in? Well, so the runtimes that I'm responsible for have always been, and to my mind always will be, based on open standards APIs. Their open standards are, or the openness of the Java EE APIs are the reason why Java EE was so successful, and the reason why Jakarta EE will follow in its footsteps, and the reason why MicroProfile will be successful. Having multiple vendors implementing those APIs and giving customers choice is I guess where customers want to be. They don't want to be locked in. So Java EE, I'm kind of probably preaching to the choir here, but Java EE has been around for a long time and evolved over the years. Its progress slowed in recent years, which is why a group of vendors got together and created MicroProfile, which rapidly moved to Eclipse and the Eclipse MicroProfile project. Now it says optimizing enterprise Java for a microservice architecture, but I actually feel that one of the things we don't say often enough about MicroProfile is how it can complement your existing enterprise applications, your maybe monolithic applications. Because if you're moving those into the cloud and you're containerizing those things and putting them in a Kubernetes environment, then you want to be able to integrate with the observability capabilities of that platform, so metrics, health, and so on. And you want to be able to have that container that you've put your existing application into be properly managed by the Kubernetes environment, so the health capabilities of MicroProfile, for example. And of course, Jakarta EE is coming along with Jakarta EE 9 and 9.1, which gives us a path forward for the Java EE capabilities. And it actually, well, I guess I'll talk about it on the next slide, it actually kind of lowers the barrier to entry for vendors in terms of certification. So just having slide challenges there. Okay, so Jakarta EE is very important to OpenLiberty. So we have Jakarta EE compatibility in OpenLiberty version, the OpenLiberty beta. So we have compatibility for 9 and 9.1. And I fully expect us to have compatibility in a GA product, OpenLiberty and also WebSphere Liberty. And I think, as I was saying, the fact that Jakarta EE it's easier for vendors to get certification. The bar is lower. I think is a great thing, because the more implementations, the more trust customers will place in the technology. So why do I think Liberty is a good choice for doing these cloud applications, containerized applications? So Liberty is a lightweight runtime. We wrote a small lightweight kernel and then essentially took the Java EE and Jakarta EE capabilities and componentized those into the runtime. So you can pick and choose what capabilities you want to use based on your application needs. So that means you can, which is kind of a very good fit for the model nowadays, where applications are the things that you develop and you bring the runtime along for the ride. You want that runtime to fit the needs of your applications. This can reduce the costs of your deployments. Also, Liberty is very efficient, especially when you couple it with the Eclipse OpenJ9 JVM. And we find that it can be in the region of kind of 4 times more efficient than Tomcat, for example, and also has similar efficiencies over other runtimes. Next couple of reasons, so continuous delivery and zero migration. We've worked very hard with OpenLiberty to make it fit well with kind of the way modern applications are being developed and deployed nowadays. So the ability to essentially commit a change, go through a continuous integration, continuous delivery phase, even continuous deployment. So it's very easy with runtimes to build up technical debt if you're not consciously managing the state of that application. You're not keeping up to date with security fixes and so on. Whereas with Liberty, continuous delivery, we release Liberty every 4 weeks. We actually release the containers every week. And we provide security fixes, critical security fixes as part of those releases. And every 4 weeks we release, when we do a release, we roll in the security any fixes from the previous release. So you don't need to really apply security fixes anymore. And if you couple that with zero migration, where we actually say that if you don't change your application, you don't change your server configuration, then we won't change the behavior of the runtime. Then that means you can just as part of your pipeline, pick up the latest release of Liberty, run it through your build, run your tests, and then go into production. There's no migration anymore, which can be costly and be a reason why you pick up technical debt, because you avoid doing those migrations. Last couple, so Kubernetes optimized. The runtime is self-tuning in terms of its thread pool, so it tunes to get the optimal performance for the environment you deploy it into, which is great for containers if you're going to build a container and then deploy that into different environments. It also adapts over time, so if things like latency change in the environment, the runtime will continue to optimize and give you the optimal performance. We also, as Rez is going to demonstrate, have an operator to make it easy to deploy into Kubernetes and OpenShift. Lastly, developer experience. So we work very hard to make it easy to develop for Liberty. We have a rapid in-the-loop developer experience where you can just save code, save configuration changes. They automatically get picked up, and you don't have a server restart as part of that. And we also have that capability as part of containers as well. So you can do development in an environment that's going to be very near to your production deployment. Okay, so that's enough of me prattling on. So we'll hand over to Reza, who's going to do the demo. And you're on mute, Reza. I know you haven't started speaking yet, but
All right. So do let me know when you see my screen, Graham. So just if you can just confirm that for me, then we'll get started here.
Yeah, I'm currently seeing my screen. Do I need to stop sharing?
I am not really sure. Let's try that once again.
I've stopped my sharing.
Okay. Let me try this one more time. I think it's a little bit tricky. Okay. You still can't see my screen, can you? At least I can. So let's try that one more time and see if that works. Share screen. Okay, I think now you can see my screen.
Yep, that's good. Yep.
Okay. All right. So let's get started here. All right. So what Graham and I are actually going to talk about today is show you how to run Liberty on Azure Red Hat OpenShift. So what is all of this about Liberty? Graham already talked to you about. What Azure Red Hat OpenShift is basically a managed OpenShift version, and we'll talk about OpenShift a little bit if you haven't seen OpenShift before either. But OpenShift basically is an abstraction over Kubernetes, if you will. And we have a managed version of it. So you can run OpenShift by yourself and do all the setup by yourself, but why would you ever do that? So Azure basically has a version of OpenShift that is just canned, right? You just point and click, and lo and behold, there's your OpenShift environment all set up. And that's what we're going to show you today. So as Graham also talked about, we basically have this partnership to get all flavors of WebSphere running well on Azure. So that includes Liberty, includes WebSphere Traditional, and we'll talk a bit more about that roadmap. And what we're talking about today is actually just a part of that roadmap. So right now, the state of where this particular work stream is that we provide you step-by-step guidance on how to do these things. So that's what you're looking at right now, is this page that I have linked, and I've shared the link in the chat. This is what this guidance is all about. If you follow this guidance, you should be able to get Open Liberty up and running on Azure Red Hat OpenShift fairly easily. And in fact, it's so easy that we can even venture to show you this in the span of about 30 minutes or so. And that's what I'll be doing with you. Is basically more or less going through this guidance. So let's begin to do that. I'm gonna obviously not do a lot of it. If I did do it end to end, it would probably take me about 4 to 5 hours, maybe even about 8 hours. So obviously we don't have 8 hours right now. So what I've done is I've done a little bit of setup ahead of time, but I will talk you through exactly what the setup is. And obviously some portion of this, namely the actual application deployment portion, that we will do in real time. So there's some prerequisites. I already have the prerequisite set up. It's not too exotic. It's like Java, Maven, Docker, the Azure CLI, which you will need to interact with Azure, as well as the OpenShift CLI and Kubernetes CLI, which is also installed. There is a code example. So the code example is on GitHub. This is what I'll be showing you today is just a variant of that code example, a little bit of a variant, not that much. But the code example is actually on GitHub also. You can try that out. The first step you're going to do is create a Azure Red Hat OpenShift cluster. And if you go through these steps, they are a little bit non-trivial, right? So there's a number of setup steps that you need to do in order to get even Azure Red Hat OpenShift up and running. We'll talk a little bit later on this talk how we make that easier. But as you can see, quite a few steps to get the Azure Red Hat OpenShift environment up and running, which I do have. So if I go to my Azure portal, so this is how the Azure portal looks like if you haven't seen that before. And if I go to Liberty Azure Demo, and if I try to make this a little bit better visible, this is a lot of stuff going on in the portal. But there's your Azure Red Hat OpenShift cluster up and running. So if I click on this, you'll see it says OpenShift cluster, and then there's a bunch of things going on in here. So that I already have set up following these instructions. Then I've also connected up to my Azure Red Hat OpenShift cluster, and I'll show you that in a moment. I'll actually explicitly connect to the OpenShift cluster using the OpenShift command line, which is OC. Right, and I'll show you how to connect up with OC. So how OC talks to this remote OpenShift cluster that I've created. But basically, once you connect up to your OpenShift cluster, you'll get something like this, and I'll show you this in a moment also. So if you haven't seen this before, this is the OpenShift console, and I'm logged in as myself. But actually, let me log out and sort of start from the beginning and log in as what's called the cube admin or the cube administrator. So this is the administrator for the entire OpenShift cluster. And as you'll see, there's a little bit of a warning that says, hey, you are an administrative user. Don't try to do too much stuff as an admin. But this is the admin OpenShift cluster. So once you connect up, this is what you will see following these instructions. And then you will enable what's called the Azure container, OpenShift container registry. So in order to do anything with containers, you need a registry of some kind. Probably the best known one is the one from Docker. So Docker Hub is the most popular one. But typically when you're doing production deployments, you don't want to be using an open source one, and it's really not a public repo. So there's various container registries you can use. GitHub even has one. Azure certainly comes one, is the Azure Container Registry. But if you're using OpenShift anyway, OpenShift also comes with a built-in container registry. And in fact, if you're going to use Azure Red Hat OpenShift, this is the one we actually recommend, and the one we outline in the guidance, and the one I'll show you today. Right. So you need to go through again a few different steps to enable that container registry as well, and to set yourself up as a user. So you need to create a namespace. I'll show you the namespace, and basically assign this namespace to a app administrator, right, or the person actually doing the application deployments rather than the cluster administrator. And I'll show you that distinction in a moment. So these are all of the things that I've done so far, and I've also installed the OpenShift or Liberty OpenShift operator. I'll talk a bit about the operator, but you also need to install it in order for this demo to work. It's basically what you see is what you get. You can do that through the OpenShift portal, or rather the OpenShift console, and it's basically a few steps of a wizard that you need to follow in order to get the OpenShift operator installed, and that is also all installed. So this is the point that we are in right now. So everything is set up. I've set up the OpenShift cluster on Azure. I've connected up to the OpenShift cluster, enabled the container registry, enabled the operator, and now we're ready to basically deploy the application. So let me show you the end result a little bit. And the best way to do that is just to basically look through the admin console here. So this is the Red Hat OpenShift admin console. I can now close the Azure portal. When you're using OpenShift, honestly, you don't really need to use the Azure portal that much, other than just deploying the cluster itself. I've also deployed a data source in here. You'll see that. I'll show you, just briefly give you a glimpse of it. There's a Postgres database running here. So as you can see, Azure database for Postgres server. But other than that, there's not really much to see in the portal. So let's close down the portal window, Azure portal. This is where we'll be doing a lot of our work. So this is the OpenShift console. Okay, so I'm logged on as an administrator, which means I can see anything and everything on this cluster. As you'll see, there's a number of information, metrics related information that you'll see for the cluster itself. So CPU memory utilization, network, pod count, and so on. But you'll also see projects, and I've created several projects here, but the most important one is going to be this one here, Liberty Azure Demo. Okay, so this is the one where we will actually be deploying the application. It's a namespace that I have created. And the other thing you need to understand is the installed operators. So here I have the Open Liberty operator. We'll actually be doing the application deployment through the Open Liberty operator. So it has a number of features into it. Other than managing and deploying the application, you can also do distributed tracing and dumps. This is another capability built into the operator. We won't be getting into the tracing and dump, but we'll definitely will do the deployment. So there's a number of other things going on here, but I'll show you the user. So here's a user that I have assigned. I've assigned myself as a user here. So this is where I'll be doing majority of my work as opposed to trying to do this as the administrator. So I'm going to log off now and log back in as myself rather than the cube administrator. So log out, log in. And here's me, and you see I have a much smaller, a much simpler window here. So I just have the access to two different namespaces. I have access to the registry because I'll be deploying onto the registry, OpenShift image registry, as you can see here. Maybe I'll increase the font size a little bit here. I think that should be doable. Yeah. So there's a container registry, and here's my application namespace where I'll be doing the deployment. The other things I will show you in a moment, but you can see if I go to installed operators. Sorry, I need to pick a project first. So projects, and we'll pick the project there. And if I go to installed operators, you'll also see that I have access. I've given myself access to the operator. But other than that, the workloads, there's not really anything here. No pods. No deployments. It's basically a clean namespace at this point. But we'll take a look at this a little bit later after we do the deployment. By the way, I forgot to mention, for the purposes of this talk, don't hold your questions until the end. Feel free to ask questions throughout the session. Just use the Q&A function that is in the presentation widget, or just post your question on the chat, however you'd like it. I guess Graham and I will flip-flop here, but when I'm speaking, probably Graham can stop me and sort of queue any questions, pull any questions my way that needs to be addressed. I think we can shut this down also. I kind of have a cheat sheet for the rest of these steps. But this is probably the most important takeaway in terms of your demo here. If you're going to replicate the demo or try this out yourself, this is the URL that you will go to. Okay, so we'll keep the console open. So I do have the application downloaded, the GitHub application from the GitHub repo downloaded onto my machine. I've set everything up here. The first thing we're going to do is just run the application. So I have the application set up. It's just a Maven application. You can set it up in any IDE. I've set it up in the Eclipse IDE here. I'll show you the POM XML for it. It's very, very simple. It really is just got one dependency in terms of the application. We will use some MicroProfile features, as I'll show you in a second. We'll use MicroProfile Health and MicroProfile Open API, but those do not need to be application dependencies. So really, the application is purely a Jakarta EE 8 application, as you can see from the POM XML. Pretty simple stuff. I won't explore the application here too much because that's not our main point actually in today's session, but I'll show you just bits and pieces of it. So I'll show you the REST interface. This is the REST interface for the application. Hopefully you can see my font. If you cannot see my font, please do let me know. I think hopefully the font size is okay. So here's a Jaxaris endpoint. It's basically a CRUD application. There's a get. There's a post, there's a get all, if you will. So get without any parameters. There's a get with an ID to get a specific instance of a coffee in this case, and then there's a delete. And so if you dig into this a little bit more, as you can see, there's a JPA interface. So there's a repository. It's a stateless session bean. We're injecting the entity manager and doing a few entity manager references, and we also have a JSF portion of this application as well. Okay, so again, application is not the main point. It's not terribly fancy, but mainly it's just a plain Jakarta EE application. So let's run the application real quick to give you a flavor for what it is. So we'll run the application locally. Okay. As you can see, Open Liberty is pretty fast. You can actually, this is even, I'm running it in a fairly unoptimized way. So even in an unoptimized way, it's about 3 seconds or so, which I think is pretty reasonable. So we'll take this application. Let's open it up in a real browser for a second. So here's the JSF UI. If you want to take a look at the REST interface, I'll show you that also. So here's the REST interface. This is an XML representation. I could get a JSON representation. In fact, I'll show you the JSON representation in a second. There's 2 bits of data that I already entered. Let's enter a third one. Say coffee 3. And give it some price. Okay, so there's the application. It's a simple CRUD application. Again, nothing too fancy. JSF front end, JAX-RS, JPA, EJB, all of the JSON binding, all of the APIs that you would expect in a Jakarta EE application. Okay, so let me shut down the application. I don't really need it anymore here. And by the way, the application is talking to basically a database on the cloud. Right, so it's connecting up to the Postgres instance that I have up and running on Azure. So once I've done that, let me just, for good measure, yes, that's fine. I don't want to be too paranoid. I just like doing a Maven clean and build just to make sure things don't fall apart on me at the last minute. So I'm just going to do a Maven clean from in here and just do a quick Maven build. Okay, so now I have a fresh WAR file ready to go. So out of that process, I should have had a WAR file. So there you go. The WAR file is now built. Now what we're going to do is, the next step for us to do anything with this is we need to create a Docker image. So we have the WAR file. We're going to package up this WAR file into a Docker image, including the Java, the JDK, as well as OpenLiberty itself. Okay, so the way we do that is we create a Docker image through a Docker file. So here's the Docker file. Let me actually first before I even do that, next thing I need to do is log on onto the OC. Okay, so here's my OpenShift console, right? But what I want to do is use the OpenShift CLI for the next few things. So in order to do that, I say copy login command, and I log in as myself one more time. And this is the login command. So I just need to copy this guy here. And I have just a console open here. And I'm going to copy this in so that my OC, my OpenShift command line, is connected up to my running instance of OpenShift or Azure Red Hat OpenShift. So as you can see, I'm logged in, and I say I'm connected to the same things that you see in the console, which is the application namespace as well as the container registry. So that we're all good there. So next thing I'm going to do is actually build. No need to build the application WAR file. We're just going to build the Docker image. So let me build it, and then I'll show you the Docker file that we're using for the build. So as you can see, if I do an ls here, I'm in the directory where the Docker file actually is. So I'm going to do a Docker build. I'm going to give it a name, Jakarta EE Cafe, give it a version v1, and ask it to take a look at the Docker file in the current directory. So let's build this. Shouldn't take too long. Everything should be cached in my system because I built this earlier in the day. Yeah, so this is all done. So let's take a quick look at the Docker file. So I will tell you here, I'm cheating a little bit here as well. I'll explain why. So when one of the nice features that you get out of OpenLiberty is that OpenLiberty will try to optimize itself as much as possible to run in a containerized environment. And it does that through something called configure.sh, the configure.sh script. And I'll show you how that looks like in a moment after I show you this rendition of the Docker file. So basically, I'm not doing that because what happens is when you run the configure.sh, it takes a little bit of time. That script really tries hard to optimize the Docker image, and that takes I think at sometimes even up to a minute. Right? It's similar to what would happen when you're doing a Graal build with Quarkus. Right? Quarkus is faster at runtime, but Compile time, yeah, it's not as fast as you might hope. So in order for me to get things through the demo as quickly as possible, what I'm doing is I'm not using the configure.sh script. I'm basically starting from a very unoptimized version of OpenLiberty, which is just the OpenLiberty latest image. So it's got everything in it. It's got basically a full Jakarta EE environment. Then I need to connect to a database, so I need a Postgres driver. So I'm copying that over into the image. I need a server.xml file that has all of my configuration in it, and I will show you the server.xml in just a moment. It's got the most important things I'm doing there is configuring the database and also enabling MicroProfile Health and MicroProfile Open API, and then simply copying over my WAR file. So if there's time, I think there is enough time. So let me just show you yes.
I was just going to say, whilst you're there, so Majid asked, could you please demo DB connection? Don't know whether that's showing the configuration. Or...
That's fine. So if you look at in here, I think, so this is the configure.sh version. Okay, so the script takes a little bit of time to run. And as you can see, this is running from the base image, base UBI image. So really just the Liberty kernel as opposed to the one I'm running now. Okay. So let's take a look at the server.xml file real quick. So here is the features that I've enabled in Liberty. So again, unoptimized, just full Jakarta E8 or Java E8. I am enabling MicroProfile Health. I'll demo that in a second. And I'm also enabling MicroProfile Open API, which I'll also show you in just a second here. So other than that, pretty vanilla stuff, really. So, but the most important thing to show here's the database connectivity. Okay, so here's where I'm referring to the driver. All right, that is in the image. Here is the configuration for the JDBC driver itself, and here's the data source configuration. Okay, so in the data source configuration, I'm basically configuring a Postgres driver, giving it a JNDI name, and telling it which database it should look at. So the database name is Postgres, and the password, server name, and user information is actually going to be passed in as environment variables into the Docker image, and I'll show you that in a moment. And the same thing when we run an OpenShift. This will still be passed in as environment variables. Okay, so that's the database connectivity information there. All right, so we built the Docker image. The Docker image is ready to go. Now we're going to actually run the Docker image just as a sanity check. Okay, so I'll show you the syntax for that. Right. So here's the syntax for that. Docker run. IT stands for interactive. I want this in the foreground. I am exposing port 9080. Otherwise, I won't be able to even access the server because each time you run a Docker image, it basically runs it in its own network. And that's the database information that I'm passing in. So as you can see, I have the database up and running on Azure. So I'm simply pointing to that database and passing it the database server name, the user, as well as the password, and then running the Docker image. So let's give it a run. And this will run a tiny bit faster than my IDE for sure. Okay, so there is the application up and running again. So let's go ahead and access it through the browser one more time. Okay, so there is the application. Let me just delete this last one here, and I'll show you the MicroProfile Health endpoint. We will be using it through OpenShift, and even you can use it in Kubernetes. So here's MicroProfile Health. It says yes, the status of of Liberty is up. We can see if Liberty is live. Yes, it is live. And we can see if Liberty is ready. Obviously, it is ready because I just, we're accessing the application with the browser, so it is up and running. Next, I'll also show you MicroProfile Open API. So once you enable MicroProfile Open API, you get this kind of stuff. So as you know, I do have a REST endpoint. So basically, MicroProfile Open API is detecting that I have that endpoint and publishing the endpoint information. Right. So here's the URL, Jakarta EE Cafe, REST coffee. There's with the ID is I can get a coffee by the ID. There's a delete operation. There's a get operation at rest coffees that will get you all the coffees. So all of this information is there. Now, you can also do something more as well. There's also the OpenAPI UI. Okay, and what this gives you is that it reads all that metadata information out of Swagger and gives you a UI that you can exercise your REST endpoint. So I just have one REST endpoint, as you know, with these operations. So get, delete, post, so on. So we'll just do the simple one. We'll do a get all. So let's take a look at. I promise you, I'll show you the JSON interface. So I'll do that. So we'll say media type is JSON. Okay. And we'll just execute this, try this out. And there's the information, right? So there's coffee 1, et cetera, coffee 2, and we're getting the response headers as well. So that's MicroProfile health and MicroProfile Open API in action. So I'll show you in a moment how this interacts with OpenShift. Okay, so let's control C this. So this is going to kill the Docker image. The next step for us is to actually tag this Docker image. Okay, so right now it's just untagged, which is fine for running locally. In order for me to push this Docker image, I need to tag it with the appropriate repository name. Okay, so I'm going to do Docker tag, give it the local name, and then what I want to tag it as, which I'll need to specify the full name of the OpenShift registry, which I've retrieved ahead of time. And again, in the instructions, you'll see how you retrieve that. And I'm giving it also the namespace, which happens to be Open Liberty Azure Demo, and then the same name as the application, and then the version. So we'll tag it here. Okay, it's done. Now I'm ready to push the Docker image into the container registry. But before I do that, I need to log onto the registry, which is what I'm doing right now. Okay, taking a bit longer this morning, maybe a little bit of network latency. Okay, so login has succeeded. Good. All right, now we're ready to push the Docker image onto the registry. So we'll go ahead and do that next. All right, so it's Docker push, and then the full name of the Docker image. So let's do that. And this should be quick because I pushed it earlier in the morning, as I said. Yep. So everything should the only thing that really should have been pushed, because everything works based on Docker layering. So really, the only change was my fresh WAR file. Okay. All of the other rest of the layers, including the Open Liberty, which is probably the biggest piece, the biggest layer, and the operating system and the Java version, all of that already exists. Now, if I had used the configure.sh, this would have taken a bit longer because it's sort of the layering no longer works because the configure.sh script is generated every single time. Okay, so this will take longer if you do the configure.sh way. Okay, so finally, we're going to actually deploy the application. Now, here's the artifact that we will need. So in order to deploy the application, just like in Java EE, you have deployment descriptors like the web XML file or the application.xml file. In order for things to work in Kubernetes and OpenShift, you need a similar descriptor. Okay, so this is what the descriptor is going to be. And the descriptor in this case is going to be written in terms of the operator. And I'll explain what I mean by that in a second. So to keep things simple, we're just going to deploy it through the OpenShift console. You can deploy it through the command line. Doing it through the console is just a tiny bit easier, especially for demo purposes. You'll actually be able to see what exactly is going on. So first thing is we're going to do is select the namespace. Okay, so we're in the correct namespace. This is the namespace that we were going to deploy our application into. Now we're going to go to the installed operators, and we're going to do the deployment through the operator. And as you can see, here's the operator installed, and it has several different operations. So let's go in here. So there's several operations in here. There's the actual details of the operator itself, okay, which is a bit of documentation, and what exactly the install events for that. There's a YAML for the operator. Typically, you don't want to mess with that. Here are all the events. No events in this operator yet because we haven't deployed anything. So these are all of the instances. But here's where we're going to be at, right? So there's Open Liberty application that allows you to deploy the application and undeploy the application and manage the application. There's a Liberty Trace and Liberty Dump, which we won't show you today. So let's go to the Open Liberty application. And there's no Open Liberty applications right now, so we're going to create one. Okay, so I'm going to hit Create Open Liberty application. You can do it through what you see as a what you get editor here, but we won't do that. We'll because we already have the YAML file ready, YAML deployment descriptor ready, and I'll show you the YAML deployment descriptor. So it is a type of Open Liberty application. This is referring to the operator. This is how you're referring to the operator, and the rest of the syntax is configuring the operator for this particular deployment. So we're going to give it a name. We're going to tell it what namespace we are deploying to. We want 2 copies of Open Liberty running because we want it load balanced. We're specifying the application image name, and this is referring to the image that we just pushed. Pull policy is always, doesn't matter, you can use any pull policy. I prefer to use always just to get fresh copies of all of the images when I can. I am going to expose this, and what this is going to do is that after the deployment is complete, it's going to expose those endpoints through basically a load balancer and an application gateway. That's what the exposed equals true means. I will need to pass in the environment variables. In a production environment, you would actually want to pass this in through Kubernetes secrets. For demo purposes, I just have the environment variables defined here. And remember, this is what's going to get ultimately propagated into the server.xml file. And here is where I have the readiness and liveness probes configured. And you'll see that I'm actually reading the MicroProfile health endpoint APIs. So if there's anything that goes wrong with the server, it will show up through the health probes. Okay, and the OpenShift and Kubernetes runtime will handle it appropriately. Okay, it'll make sure that requests don't get routed to an unhealthy endpoint, or if a pod needs to be restarted, it's going to go ahead and restart the pods. That's what all this configuration is essentially about, and you can tune things like initial delays and timeouts and so on and so forth. So let's just copy this guy over, and we're going to paste it on here. I like to double check that things are okay, so I flip back to the form view. And all of those values that I entered are pre-populated. So there's my name. There's the application image that I want. Pull policy as always is fine. I have 2 replicas. I could increase it to 3. It is exposed, as you can see, automatically creates HTTP route. I think the rest of it is okay, and we're just going to hit create here. All right. So after we create here, hit the create button, here's the application. We'll actually monitor that the application is deploying okay. And the way you do that is if you hop back in here, you'll see a number of resources. First, we want to check the state of the deployment. So let's take a look at the pods. And you see it's not quite ready yet. I have 3 pods that are going to be scheduled. 2 of them are running. This one should be running fairly shortly. Let's just give it just a few seconds here. And actually, if we wanted to, we could hop back in here and take a look at the events for each of these. Okay, so as you can see, it's getting scheduled, pulling the Docker image. So all of those details are actually present here. I bet our deployment is done. Yeah, the deployment is done. And in fact, you can even go further. If you can actually take a look at the logs of these machines also. Right, so this is all of the log information that is there. Okay, so if you go at the very end, it should say something like smarter planet, ready to run a smarter planet or something like that. Yeah. Okay, default server is ready to run smarter planet. Jakarta EE cafe initialization successful. So all of our images are actually now up and ready to go. So next, let's take a look at the actual routes. So here's the route that was deployed for us. Let's go into the route. This is the actual location where the application is run. So let's access that. So we're accessing Open Liberty. I could have configured the application to run on root. Just wanted to show you that we are running Open Liberty. Let's access the application next. So there's the application. And we can also actually check out the health endpoints here as well. Sometimes Chrome gets a little bit smarter than it should be. Okay, so it automatically added HTTPS, and I haven't enabled HTTPS in the application. So that's up and running, and we can also similarly take a look at the OpenAPI endpoint. Man, this is so annoying. Yeah, there we go. Have it. That's all the information that we have. In fact, let's try the get functionality here for a second. Try it out. Gonna give it an ID of 1. Execute it, and yeah, there's my coffee with ID 1. Okay, so I think that's about what I wanted to show you here. Oh, yeah, I did want to show you around the console just a little bit more. Okay, so as you can see, the application is up and running. Now, if you go to pods, you'll see that the pod information is there. You can take a look at all kinds of information about the pods. You can even terminal into the pod itself. So if I go on ls here, let me expand this. You'll see that we're actually literally in the pod, right? So you can even do that through the console if you like. Obviously, you can see the events. We showed the logs already. The environment variables that I passed in should be visible here. Okay, for some reason it's not letting me scroll. So there's a deployment. We've already seen that before. There's no configuration that I've specified. If you're going to use secrets, they would have showed up here. Yeah, as you can see, there's a number of secrets. You can configure those here and then pull them into your environment variables. If you look at the services, I do have a service created, and as you can see, I do have a route. If I wanted ingresses configured, I could have those as well. Okay, so that is basically a little bit of to show you a little bit of how things look like in terms of the experience for Liberty using OpenShift. Okay, so I think that's about it. Unless there's any other questions, was there any real questions, Graham, that I can answer? Otherwise, I'm going to hand back to you. So. Yes, you can absolutely configure security the same way you would. Graham, you're on mute.
I was on mute, yes.
Okay, so what about security? Yes, we have some samples for this also. Let me show you the samples. I think I have. I'm still sharing my screen. So if you look at Open Liberty, you see Liberty LDAP AAD. I think Liberty AAD. I think should do it for us. Liberty. Here. And of course, my mouse doesn't work. AAD is what I wanted. AAD. AD. Okay. So you have an example for that also, right? So
yeah.
we've written up a blog entry on how you would do that. More or less, it works the same way as it would in an on-premise environment. So what you would do here is you would configure Open Liberty with connectivity, would secure your application through Open Liberty. You would point to Azure Active Directory or some other security mechanism, and we'll tell you how. We tell you in these guides how you actually do that, and you can deploy it, through the Docker image, through OpenShift, just the way we showed in our demo today. Okay, so if there's no other questions, let me stop sharing, and we'll go back to the slides for a minute. We do have some important material to cover there, specifically our roadmap.
Okay. All right. Hopefully you can see the slides now. Okay. So thanks for the demo, Reza. It's very good as ever. So in terms of the kind of scope of the collaboration and roadmap, so Reza alluded to this earlier on in his segment. So we're working together to essentially enable existing Java EE applications on WebSphere to be moved, traditional WebSphere to be moved to Azure. We think they're typically going to be moved to Azure virtual machines or kept in virtual machines. So that's kind of what we've enabled today. So that's available as an offering on the Azure marketplace. The capabilities that Reza demonstrated here with Open Liberty on OpenShift, you can do with WebSphere Liberty, but we're also looking at providing kind of first-class marketplace entries for that, as well as Open Liberty and WebSphere Liberty marketplace entries for Azure on Azure Kubernetes services. The Azure Kubernetes service. And then, of course, once you're in the Azure cloud, you have access to the various other services. Reza demoed Postgres, you've got access to Azure Active Directory and so on. Also the ability to link out to on-premise for things like database and that kind of thing. And if you're in Red Hat OpenShift, of course, you've got access to the various services that are available in the OpenShift environment as well. Anything you want to add, Reza?
Sorry, my mouse is acting up. I apologize. So the main thing to understand here is that there's multiple levels of things that we are offering. So for VMs, I mean, we're just offering the VM offering. There's not really much to do there. So you go onto the marketplace and it very easily lets you create a VM-based environment with your traditional clustering. For the Liberty and AKS and ARO pieces, we're providing a couple of layers of support. So number one support is what you saw today, which is just basic guidance. But what the marketplace entries will do, which hopefully will be coming out sooner rather than later, is if you go through the documentation, again, it's not horrible, but it is work, right? So there's a number of things you need to do in order to before things will start working. So what the marketplace entries for Liberty and ARO and AKS will do is automate all of that for you, okay, in a very simple way. So you'll just go through the marketplace entry, fill out a few entries on a window, and lo and behold, will give you an initial working environment. And definitely above and beyond that, the other layer is the things we talked about. So enabling all of the integration. So once you're in Azure, you should be able to use Azure infrastructure of various kinds, whether it's databases or Active Directory or distributed logging, and the same goes for ARO, right? ARO comes out of the box with a number of these services as well. So we're trying to provide guidance in that dimension as well. So once you have your application up and running, you need to use all of the other different things to connect up your application with to do useful enterprisey stuff. So yeah, I mean, just stay tuned. You know, we'll continue. We have an active partnership, and we'll continue to produce these roadmap items. But I think the most important thing that I'd like to share with you, and I'll share a survey with you in a moment here, is you can, because of where we are in terms of our product development, you can actually work with the engineering team directly on your migration cases. So all you really need to do in order to do that is reach out to us in one way or the other. I'll give you one of the ways, which is just fill out the survey. And as soon as you do that, we can begin to work with you. So I hope that's an important takeaway for you today as well.
Yeah. Also, the bottom left-hand link on this slide, you can go there and click on the contact me and fill that out, and that's the way for us to get in touch with you and help you. So this is just some hopefully useful links for you if you're interested in Liberty, reading more about Liberty, or watching some videos about Liberty. Or on the right-hand side, we've got some things to try out. There's the guidance that Reza's essentially walked through for Red Hat OpenShift, or equivalent guidance for the Azure Kubernetes service, or getting started with Liberty. We have a guide for that, and then there's a bunch of guides in the Open Liberty IO project around Java EE, Jakarta EE, MicroProfile, containers, Kubernetes, and so on. All hands-on things that can help you learn those technologies and get familiar with them. So with that, I think we're done, unless there are any more questions. So I really appreciate you coming along to listen and lasting out the hour.
Yeah, so I'll just jump in here and say thank you for that excellent presentation today. And just a reminder to everyone in the audience, if you have any final questions, please feel free to throw them in the chat now, and I'm sure they'd be more than happy to answer them for you as I wrap up here. So just to let you guys all know, the next Jakarta Tech Talk happens June 29th with Jared Anderson as he joins to present Jakarta EE 9 and 9.1 with Open Liberty. And you can register for that as I put it in the chat here now. And we are also looking to book more Jakarta Tech Talks throughout the summer and 2021. So if you're interested in presenting, you can fill out this form. I'll put in the chat. And if you guys have any feedback on today, you can just put it in the green button that just appeared on your screen. And I don't think there are any other questions. So I just want to thank everyone for attending. And thanks again to Reza and Graham for the excellent presentation today. And I hope you all have a great afternoon.